So what I've done again is using my set square. I've drawn this right angle. I've marked off 12 centimeters on the side, 5 centimeters here. If you could draw the same, please, and then connect them. Okay, draw the hypotenuse and measure it and see, does this relationship hold for this triangle? So I'm going to call this distance x, and what I want to know is it true that 5 times 5 plus 12 times 12 gives me x, whatever that is, multiplied by x. Okay, so pause the video and see how you get on. So hopefully we're finding it's 13 centimeters is the hypotenuse. So is this the case? Well, 5 times 5 is 25. 12 times 12 is 144. You add them together, you get 169, which is 13 times 13. So yeah, that relationship holds there again. We'll try one more. Okay, so again, if you could take your set square, draw yourself your right angle, mark yourself 8 centimeters on one side and 6 centimeters on the other. This time, before we actually draw in the hypotenuse, I'd like you to predict how long it is. Okay, so pause the video and see if you can predict the length of it using our relationship, which is 6 times 6 plus 8 times 8. Will that give our hypotenuse? Well, what are we going to get? 36 plus 64. We're going to get 100 equals what multiplied by itself? Okay, see if you can get that. Okay, hopefully no surprises. 10 centimeters is our hypotenuse length. And so 6 by 6 plus 8 by 8 gives 10 by 10. Well, that's 100, isn't it? So, yeah. Now, this relationship is called Pythagoras' theorem. And more correctly stated, you might say 6 squared and 8 squared gives 100 or 10 squared. Okay, that square means multiplied by itself. So you see 6 by 6 plus 8 by 8 equals 10 by 10. Some other versions of it you'll sometimes see, I'll do in a second. Yeah, the other version you'll see sometimes is, well, if you go back to this one, that was 3 centimeters, 4 centimeters, 3 by 3 plus 4 by 4 gave 25. So this, the square root of 25 is 5 centimeters, was our hypotenuse. That's the one we started off with. You'll sometimes see it written that, well, if you draw a square off the side of these triangles, that is of length 3, because that is of side 3, and draw another length square here. This one is of length 4, okay, because that side is of side 4. This theorem says the two small squares will have the same area as the bigger square. So, well, that's not surprising, because 3 by 3 is 9 centimeters squared, 4 by 4 is 16 centimeters squared, and 5 by 5 is going to give us this other square, which is 25 centimeters squared. So no huge surprises there, but you'll see this as another approach for Pythagoras. Sometimes you'll see it that the squares are of equal size. Now, sorry, let me finish this off. 5 centimeters there. Oh, it's almost 5 on the nose. Okay, so that this square is also of the same area, the big square, as the two small squares combined. Okay, I'm just going to do this a bit rough, but that's 25 centimeters squared. Okay, so that's just another version of Pythagoras' theorem, but look, it also says 3 squared plus 4 squared equals 5 squared. So that's what we're working with in this set, in this video today. Okay, so we're going to draw ourselves another set of perpendicular lines here, and you're going to mark these ones as, let's see, we'll say 12 centimeters, if we can fit that in. Can we? No, we cannot. Can we fit it in here? Okay, so we'll pick shorter, we'll pick 6 centimeters and 8 centimeters. So I think we saw this one already. Okay, and if I was to measure this, this is 8 centimeters. This one here we can see is 10 centimeters. And let's suppose we didn't know what that was. Okay, that was just an X. Well, Pythagoras' theorem would let us say that x squared plus 8 squared equals 10 squared. So that x squared plus 64 is 100. X squared is 100 minus 64. That's moving that over to the right hand side, and you have to subtract it from the right if you're adding on the left. X squared equals 36. So what value does x have? Now we knew it was 6 anyway, but it's by finding the square root of 36 is that you find the value for x there. So this is quite useful. If we know two sides of a right angle triangle, we can calculate the third. And we'll finish up with this one here, where you have two of side 5 centimeters, two sides of 5 centimeters. Let's suppose you want to say, well, what's that side? I'll call it A just for a change, or actually I'll call it B for a change. Okay, and what you'd say there is you'd say, well, B squared, the hypotenuse, the longest squared, side squared is the other two sides squared and added together. It's the sum of the squares of the other two sides. Well, that says b squared is equal to 25 plus 25, or b squared is equal to 50. And if you do the same thing we did here, you'll say, oh yeah, well, b is the square root of 50. The only problem with that is over here you're able to say, well, what's the square root of 36? And you got a whole number answer. But if we say, what's the square root of 50? You get this awful mess of an answer. Okay, that's called an irrational number, 7.071. Okay, but that's okay. You can either leave it as the square root of 50, that's called surd form, or you can write it as 7.07 if you want to. If you measure it, you'll see that, yes, my distance comes out as 7 centimeters, but look, it's a little bit over 7 centimeters. I'm not sure how clear that is in the camera, but it is a little bit over. Okay, so that's Pythagoras' theorem. We'll try some questions now. So on text and test exercise 8.5 here, you can see question 2 says your triangle is 24 and 25 in A. Find the length of A. Okay, so you can sketch these out. So you don't necessarily, when you're doing calculations, you don't need to do it perfect. Okay, just when you're doing drawings and you're learning at the start. But what does our rule say? Well, there's the hypotenuse, that's the right angle. So that side squared is equal to the other two sides squared added together. Okay, or if you prefer still, 25 times 25 is equal to 24 times 24 plus A times A. You don't have to work with the squared notation. I know some students find it a bit confusing. 25 times 25 is 625. 24 times 24 is 576 plus A multiplied by A. Okay, well, I want to move 576 over, so say 625 minus 576 gives me my A times A. Well, 625 minus 576 gives me 49. And what multiplied by itself gives 49? A is 7. Okay? Or if you'd gotten to this stage and you'd said A squared is 49, you would have said A is the square root of 49. And your calculator would have told you that that's going to give you 7. Okay, I want to look at one more, which is question 3 here. We'll go with the first one. 2, square root of 5 and x. Okay, and they've told you that the square root of number squared gets you back to, so square root of 2 squared gets you back to 2. Square root of 5 squared gets you back to 5. So with this one, we've got 2, we've got the square root of 5, and we've got our hypotenuse is our unknown. So Pythagoras says take the hypotenuse, take the unknown, x by x is the same as the other two sides multiplied by themselves and added together. Okay, so x by x equals 2 by 2 is 4, plus root 5 by root 5 is 5. Okay, and that's the bit that they kind of reminded you about at the start of the problem. A square root multiplied by itself gets you back to the original number. Okay, so that gives us x times x is 9. So x, well, 3 by 3 is 9. Nope, is 3. So x is 3, and 3 times 3 is 9. Okay, just using our square notation, that same problem would have said x squared equals 2 squared plus root 5 squared, which is 4 plus 5 or 9, and x would have been the square root of 9, which is 3. Okay,